Hello guys, my name is Sumant. I'm a third year electrical student. This week we are going to discuss some digital signal processing problems. So coming to the first sum, choose a filter to smooth out high frequency noise present in the signal, and second one, choose a filter to emphasize high slope portions, and third one, design a filter with some floor function, and the fourth one, find the output of signal processing system which performs derivative filter and then perform moving average filter. Last week we already discussed these problems, but last week what we have did is we given the input signal to these equations and then calculate the output. But this week we are going to import the data from the sensor and then we are going to perform this operation. So looking the first thing, choose a filter to smooth out high frequency noises present in the signal. For this first part, we are going to do moving average filter, and the moving average filter equation is already given here. Y of n is equal to 1 by L sigma k to 0, k from 0 to L, x of n minus k. What this moving average filter does is it will calculate the average of the k values from the nth point, like all the sum of the k values before the nth point and calculating the average of that. So looking at the code, okay, so I'll explain the code now. First I have taken the output variable, that is a y, and yeah, I already said you that we are taking the input from the sensor, like, so I created the variable sensor value and then some creating variables, and in the void setup serial.begin, I already explained you why I'm using the serial.begin of 9600. There's a transfer rate of data, and in this void loop I'm using this while I less than 500, sensor value of I is equal to analog read of a0 and delay of 10. So what this means is we are taking the data from the sensor, right? So I connected the sensor to analog, like Arduino at a0 pin. So this command will enable us to take the data from sensor to Arduino. Sensor value of I is equal to analog read of a0. That is, we are taking the continuous values. So we are using this at each and every point. Let us, for example, I is equal to 0. Sensor value of 0 is equal to, at that point, at that instant, the data comes from sensor to the Arduino through this a0 port, and we'll create some delay. Again, next, sensor value of 1, sensor value of 2, sensor value of 3, so up till sensor value of 499. We are like connected the sensor to the Arduino a0 pin and importing the data from the sensor. So that gives us the input signal. Now we have to perform the operation on it. For this, we already last week we discussed about this moving average filter code. We created some two for loops, and inside the first for loop we are using y of j is equal to y of j plus sensor value of j minus k. Like I already said you, it is taking the calculating sum of the k values before the at each and every point. It is calculating the sum of this length L values, and here we are taking the length is equal to 8. So it will calculate the sum of those previous 8 values, and dividing with 8 will give us the average. So at each and every instant we'll get the average, and then we'll print this output. So this serial.print of sensor value of I will give us the input signal, and serial.println of y of I plus 500 will give us the moving average filter. So this will give us this is the input signal, and then see we can clearly say that this got smoothened, and this is the output signal. So with this, the first part is done. Question is to pass it through the derivative filter. See, choose a filter to emphasize high slope portions in the signal. To emphasize the high portions in the signal, we have to use derivative filter. First order difference or the 3-point central difference. Anything can be fine. The first order difference is y of n is equal to x of n minus x of n minus 1. And 3-point central difference is y of n is equal to x of n minus x of n minus 2. So we can calculate the both. Again, same. I taken the variable of sensor value of 500 for the sensor input, and z of 500 for the output, I and j for the code purpose. Again, some void loop I less than 500, sensor value of I is equal to log read of a0. I already said you, we connected the Arduino and sensor through a0 pin, so I'm importing the data from the sensor through commands, and I'm giving the delay so that you get the continuous data. So, and this is the basic code for j less than j equal to 0 less than 500, z of j equal to sensor value of j minus sensor value of j minus 1. The difference between each and every point and each value and its previous value, that gives us the derivative output of that particular instant. So serial.print of this input signal and this is the output signal, and plus 400, that is because to not to, if not given for plus 400 they both will merge, so and will get confused. So to avoid that problem I'm adding plus 400 so that the output value will shift above. In similar way, if we command this and we uncommand this, this will give us the expression for 3-point central difference. The one is for single derivative filter. This is for 3-point central difference. The difference is here x minus 1 and here x minus 2. That's the basic difference. As of now, we are calculating for single derivative filter. So implementing the code, and the output will be look like this. The input, this is the input signal, and we can clearly say in the output signal we are getting the emphasized portions. So coming back, third code. Third one is to basically apply a floor function. See, design MA filter with L equal to floor of 0.8 into n to extract baseline drift component from the signal. That is to here, like we are using n of 500, right? So the length will be 0.8 into 250. Sorry, we are using 250 values, right? So given it is 0.8 into n, so we are using 0.8 into 250, and we should actually divide it by 1 to make sure that if in case 0.8 into some number is not an exact integer, to make it as an equal integer floor, after applying it for floor function, we should divide it by 1. The remaining all will be the similar case as of the first question, same the moving average filter with the same length, but in the first case we are using the length of 8. Here we are using the length of 0.8 star 250 divided by 1, that is approximately is equal to 200. So in this case we are using the length of 200, and again we are calculating this moving average filter, the same part, and again I am shifting this output plus 200 so that we'll get some clarity of what is what. And here we'll get like this, because as we use the length is 200, it will get way more smoother, and the output function will look like this. The blue one is the input signal taken through the PPG sensor, and this is the output after passing through the MA filter of length of 200. And the fourth question is find the output of signal processing system which performs derivative filter and then perform MA filter. That means like first we should pass it through the derivative filter, that is x of n minus x of n minus 1, and then again pass it through moving average filter with length is equal to, with n is equal to 8. So looking at the code of it, same in the similar case I am taking the sensor values, that is to take the input from the sensor PPG sensor, output values y of 500, z of 500. They're taking two variables for output because the first one is after the derivative filter, and the second one is after passing the derivative filter output through the MA filter. Again same serial dot begin void loop while I less than 500 sensor value of I and log read of A0. I connected the sensor to Arduino at A0 port, so I'm using it A0. If we connect it, well, let us say for example if we connected it 7th port, we should use A7, but I've connected it at A0, so I'm using A0. Delay of 10 for continuous signal. First I'm passing it through derivative filter. See, this is for derivative filter. X of x sensor value of j minus sensor value of j minus 1. This is the derivative filter output, and this y is the output of derivative filter. Again, so we are passing that y through the MA filter. You can clearly see this here. This is the code for MA filter, right? We discussed in the previous problems. By passing this derivative filter output y through MA filter, and the output of MA filter is z. Dividing it by 8 to calculate the average is sum of the 8 values before the jth point, and dividing with that gives the average. So z gives us the moving average filter output, and y gives us the derivative filter output. Sensor value is the taken input. So playing same serial dot print of sensor value input signal, y of I derivative filter output, and z of I is the moving average filter output. So calculating all this, you will get this. So the red one is the taken input, and the blue one is the output of the derivative filter, emphasizing the high